For several years, the concept of a genuinely affordable Tesla lingered in the background. Now, a compact model, expected for 2026 and targeting a price under $10,195, makes that possibility feel real. The fundamental question is whether that low price can withstand the harsh realities of production, materials, manufacturing processes, and the everyday high-quality finish buyers now expect. Can thoughtful decisions on the exterior, ranging from clear LED illumination and layered glass to straightforward aerodynamic panels, maintain a premium appearance without the associated premium expense? Inside, will comfortable surfaces, an intuitive screen layout, and quiet road behavior truly feel high-end? And underneath, can simple brake systems and suspension geometry provide comfort and stability while keeping maintenance demands low? We will examine each claim in detail, moving systematically from the body and the cabin to the hardware responsible for its motion. If you desire a clear, practical assessment as this narrative unfolds, please subscribe to Auto Fusion to assist us in reaching 10,000 subscribers and switch on the notification bell. What makes the Model 2 appear high quality at around $10,000? A well-designed lighting system is the initial success for the Tesla Model 2 because it merges a premium look with straightforward, easy-to-replace components. Instead of a complicated matrix headlight assembly, the car can utilize standard LED projectors paired with a continuous daytime running light, DRL strip. The projector lenses still provide a sharp cutoff that prevents glare for oncoming traffic, while the DRL signature remains distinctive and easily recognizable from a distance. The major benefit lies in cost and repair simplicity. High-spec matrix or laser assemblies can cost thousands more per pair when factoring in the light modules, cooling apparatus, and a dedicated control unit. A projector setup requires fewer light sources and less complex electronics. Consequently, the total component cost drops significantly, and a minor parking incident becomes a quick module swap instead of a complete light unit replacement. This allows the Model 2 to look sophisticated in the showroom and remain affordable at the body shop. Moving from visual appeal, consider the tactile experience inside the Tesla Model 2. A laminated front windscreen with an internal PVB layer, combined with side windows that block UV rays and reduce infrared heat, can make the interior noticeably quieter and cooler. Acoustic windshields have been shown to decrease high-frequency noise by up to around 6 dB, with a typical overall noise reduction in the cabin of about 2 to 3 dB. This difference, though seemingly minor on paper, is clearly perceptible on the highway. High-quality automotive glass can block approximately 99% of UV light, protecting soft-touch materials from fading, while infrared control helps reduce the parked car's temperature by several degrees Celsius. Less solar heat means the air conditioning system doesn't have to work as intensely during the initial minutes of driving, which conserves energy and helps the Tesla Model 2 achieve its expected range in warm conditions. Finally, consider where efficiency is often concealed: beneath the vehicle and around the wheels. A flat underbody panel made from recycled polypropylene smooths the airflow beneath the Tesla Model 2. Polypropylene is light, at roughly 0.90 grams per cubic centimeter, compared to steel at about $7 to $85 grams per cubic centimeter. Therefore, large components are inexpensive to mold, easy to handle on the assembly line, and cheap to replace if damaged. Smoothing the undercarriage can cut aerodynamic drag by a few points of CD, coefficient of drag, typically in the range of $0.05 to $0.10, which translates to genuine watt-hours saved at freeway speeds. Combine this with sculpted aero wheel covers that minimize air turbulence around the rims, and you achieve measurable range improvements in everyday driving. Independent tests have indicated that aero covers can enhance efficiency by approximately 3 to 4% dollars across various speed ranges. When these percentage gains are combined, the result is a clean, contemporary exterior that appears high-class while allowing the Tesla Model 2 to travel further on a single charge without requiring a more expensive, larger battery pack. You know, if the Model 2 at around $10,000 includes all three of these features, which one do you think makes the biggest difference in your daily use? A. LED projectors with a continuous DRL. B. Laminated windshield and UV-IR side glass. C. Flat PP underbody panel with aero wheel covers. Comment A, B, or C with one brief justification. How does the Model 2 make daily interactions feel satisfying and smooth while keeping the price in check? The most effective strategy is to focus first on the parts you use every day and then expand outward, as this is where perceived quality and cost-effectiveness intersect. For the window system, the Tesla Model 2 can feature standardized one-touch operation on all 4 windows and ensure compliance with anti-pinch safety standards, which require the glass to stop and reverse before the clamping force reaches approximately 100 newtons. This keeps fingers safe without requiring complex, exotic sensors. Couple this with triple-lip hollow weather strips that seal tightly, resulting in a solid, muted sound when closing the door while keeping rain and dust outside. Water management is equally important. Many manufacturers aim for a performance benchmark of around 300 Pascal spray for 10 minutes with zero water ingress during testing, a practical standard for the Model 2. Hidden pressure relief vents at the back of the car allow cabin air to escape as the door closes. The latch doesn't have to fight trapped air, so the door shuts with less effort, and the operation feels quietly superior. Following that confident closure, the next point of contact is the handle. A mechanical flush handle is a smart, balanced choice for the Tesla Model 2. Compared to motorized pop-out designs, the mechanical setup eliminates a 12-volt motor and several position sensors, removes numerous small gears and levers, and can save approximately $50 to $100 per car. Depending on production volume and supplier deals, reliability is also high. A properly engineered mechanical handle can be rated for roughly $50,000 to $100,000 opening cycles in lab tests, which aligns with years of ownership. The flush surface maintains a visually clean body line and reduces minor aerodynamic drag near the door line without adding complex mechanical parts that could increase warranty risk. Once the physical interactions are perfected, entry and startup should feel seamless. The phone as a key, PA-K feature, provides this for the Model 2 using Bluetooth technology. Under typical conditions, the car and phone connect in less than 1 second, meaning the car is unlocked as you reach for the handle. Adding ultra-wideband UWB technology improves positioning accuracy to about $10 to $30 centimeters, allowing the car to know which side you are approaching from and reducing the incorrect unlocks that can occur with simple signal strength systems. Convenience and security still require a straightforward backup. The $13.56 MHz NFC keycard serves this purpose and is available for around $40 for a 2-card set. Owners have a reliable physical credential for valet parking, phone battery emergencies, or lending the car to family members. Collectively, these choices give the Tesla Model 2 a premium daily feel that is easy to appreciate, simple to maintain, and financially prudent. How can the Model 2 offer a smooth and stable ride without an expensive multi-link suspension system? The Tesla Model 2 can begin with a basic yet highly effective setup that prioritizes stability, ride comfort, and low cost. A rear torsion beam combined with a Watts linkage keeps the axle perfectly centered as the suspension moves, ensuring the rear wheels maintain alignment through turns and at speed. Compared to a multi-link arrangement that might require 4 to 6 linkages and 6 to 8 rubber bushings, the Beam Plus Watts link system uses fewer components, weighs less, and is easier to package. Fewer joints mean less unwanted movement under load, helping the car track straight over uneven roads and reducing the minor steering corrections drivers frequently make on imperfect surfaces. Adding hydraulic bump stops with approximately $20 to $30. Millimeters of travel at the end of the suspension travel provides a small oil cushion that reduces peak wheel impact forces, allows the body to settle faster after hitting potholes, and avoids the harsh top-out sensation, all without costly adaptive hardware. Building on this foundation, the Model 2 can enhance comfort with frequency-selective dampers. These specialized dampers are soft and pliable for small, high-frequency inputs, such as surface roughness in the $10 to $15 Hz range, but they firm up for larger body movements in the $1 to $2 Hz range, such as vertical bounce, pitching, and rolling. The target is a damping ratio near $0.2 to $0.3 for primary body control, which feels composed without being excessively rigid. Because the system is entirely passive, there are no sensors, wiring harnesses, or electric motors to power and maintain. The result is comfortable city driving over rough asphalt and stable freeway confidence during crosswinds or quick lane changes, all while the parts list remains minimal and the unsprung mass stays low. To complete the package, the car will feature 4-wheel disc brakes with corrosion-resistant coated rotors, low-dust ceramic pads, and an integrated electronic parking brake, EPB, on the caliper. Zinc flake or similar coatings routinely withstand $600 to $1,000 hours in standardized salt spray tests, which is significantly better than many electroplated zinc screws. This increased resistance helps rotors avoid noticeable rust streaks after wet commutes or winter storage. Ceramic pads produce less visible brake dust than many semi-metallic compounds and offer a consistent friction curve for reliable pedal feel in daily use. An integrated EPB eliminates long steel cables and pulleys, often saving a few kilograms compared to cable systems, and it enables features like auto hold at traffic lights and easier hill starts. Rotor sizes can be modest, for example, around $260 to $280 millimeters in the front for a light, compact EV, which minimizes rotating mass and replacement expense. How is the Model 2's cabin soft to the touch yet durable and user-friendly? The best place to start is with the surfaces you interact with most frequently. Seat and armrest coverings made from 3D knit fabric derived from recycled PET can be shaped directly to the required form, resulting in minimal cutting, reduced waste, and a refined woven texture that looks high-end. Automotive interior fabrics of this quality typically meet abrasion standards of over $30,000 Martindale cycles, and many can reach approximately $100,000 cycles, ensuring the material resists wear over many years of use. For other contact points, TPO, thermoplastic olefin, skin coverings with a textured grain feel soft, resist scratching, and maintain low cabin odors. TPO skins can be heat-formed onto rigid supports, so shapes remain sharp even after the car has been exposed to the sun. The outcome is a Tesla Model 2 interior that feels premium where your hands rest without the need for expensive, high-maintenance materials. Comfort is then dictated by the seat design. A dual-density cushion combines a softer top layer that supports the body with a firmer base layer that retains its shape. An overall foam firmness of around $37 sits in a sweet spot that feels plush yet supportive during cornering or braking. This layered approach prevents the hips and lower back from sinking over time, reducing the need for numerous extra motors to compensate for wear. An optional lumbar support, either electric or an air bladder, combined with a smooth, ratchet-style height adjuster, ensures durability and precise positioning. The Model 2 invests money in physical comfort, which matters most to the body, rather than on complex features you will rarely utilize. Everyday ease of use comes from a clean interface. An 11-inch center display with an anti-glare coating and optical bonding reduces internal reflections, keeping content readable in bright sunlight. Good coatings can reduce surface reflectivity to about 1/100%, which makes graphics look sharp and reduces eye strain. A permanent HVAC control bar located just beneath the screen keeps temperature, fan speed, and defog controls immediately accessible, preventing the need to search through on-screen menus while driving. For mobile devices, a well-designed wireless charging pad is important because real-world charging efficiency is often only about 60% to 70%. Magnetic alignment and a heat-dissipating base keep phone temperatures in check. With QI2 support, standardized magnetic alignment, and up to 15 watts of charging, topping up a phone battery is faster and more reliable even in a warm cabin. Small details like these collectively contribute to a premium feeling every time you interact with the Tesla Model 2, which features help lower the Model 2's total cost of ownership, TCO, while preserving its appearance for years. Keeping TCO low while maintaining a premium look begins with the less visible components that ultimately affect an owner's bank account. The correct strategy for the Tesla Model 2 is to prioritize components that are quick to repair, slow to degrade, and resistant to corrosion. This is far more important in real-world scenarios than flashy technology that is costly to fix. Minor parking lot impacts are inevitable, so the Model 2 should turn low-speed repairs into a routine task. Bolt-on crash boxes, positioned behind the front and rear service panels, allow a technician to replace only the energy-absorbing block instead of the entire bumper assembly. For typical $10 to $15 km/h impacts, this design change can convert a multi-day structural repair into a 2 to 4 hour appointment. Parts costs are also contained. A stamped or extruded crash box is often a low hundreds of dollars item rather than a 4-figure fascia and reinforcement package, which prevents the Model 2 repair bill from skyrocketing and gets the car back on the road faster. Road debris and rain are the next consideration. Non-woven PT wheel arch liners dampen the noise from stone impacts by approximately $2 to $4 dB compared to hard plastic panels, which drivers and passengers perceive as a quieter cabin on rough roads. These liners are typically $40 to 50 Ts% lighter than rigid plastic, saving several kilograms across all 4 arches, and they shed dirt more easily after a wash. Combining the liners with an elastic underbody coating that resists chipping limits paint loss from gravel, and prevents exposed metal on the lower sills. The result for the Tesla Model 2 is a cleaner appearance over time, less need for touch-ups, and an interior that sounds better without requiring heavy sound insulation. Long-term value is then secured with intelligent corrosion control. Zinc-flaked coated fasteners typically withstand about $600 to $1,000 hours in standardized salt spray tests, significantly outperforming many standard electroplated zinc screws. This extra protection helps threads remain free after winter driving and coastal exposure. Additionally, cavity wax should be applied inside hidden seams, such as door hems, weld flanges, and frame sections. The wax seeps into tight crevices where water and salt tend to accumulate, ensuring welds stay cleaner and future disassembly is easier. Over a 5 to 10 year period, these steps reduce annoying rust repairs, minimize